Gian Emraz. Okay. Gian Anday Asuncion, Stephanie Alcantara, Katara Kun, Rasmet Alvarez, Jenny Libahan, Harvey Banag. So let's begin. Descriptive statistic. What is descriptive statistic? Descriptive statistic describe, show, and summarize the basic features of a dataset found in a given study, presented in a summary that describe the data sample and its measurements. It helps analysts to understand the data better. Descriptive statistics represent the available data sample and do not include theories, inferences, probabilities, or conclusions because it is job for inferential statistics. So descriptive statistic is just it help us so that we can understand the data better. So next slide. Measures of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such, measures of central tendency are sometimes called measure of central location. They are also classed as summary statistic. The mean, often called the average, is most likely the measure of central tendency that you are most familiar with. But there are others, such as the median and the mode. So next. The mean, median, and mode are all valid measures of central tendency. But under different conditions, some measures of central tendency become more appropriate to use than others. In the following sections, we will look at the mean, mode, and median, and learn how to calculate them and under what conditions they are most appropriate to be used. Mean. The mean is also known as M and is the most common method for finding averages. You get the mean by adding all the response values together and dividing the sum by number of responses, or N. For instance, say someone is trying to figure out how many hours a day they sleep in a week. So the data set would be the hour entries 6, 8, 7, 10, 8, 4, 9, and the values is 52. There are 7 responses. So N equals 7. So you just add the value of sum of 52, then divide it by N. So which is 7.4. So next slide. Next reporter, please.
So, good afternoon, everyone. I'm Navilin Nambiog, and today I'm going to discuss about median. So, median is the middle number found by ordering all data points and picking out the one in the middle. Or if there are two middle numbers, taking the mean of those two numbers. The median is the value in the middle of data set, meaning that 50% of data points have a value smaller or equal to the median, and 50% of data points have a value higher or equal to the median. Understanding the median. Median is the middle number in a sorted list of numbers. To determine the median value in a sequence of numbers, the numbers must first be sorted or arranged in the value order from the lowest to highest or highest to lowest. The median can be used to determine an approximate average or mean, but it is not to be confused with the actual mean. If there is an odd amount of numbers, the median value is the number that is in the middle with the same amount of numbers. If there is an even amount of numbers in the list, the middle pair must be determined, added together, and divided by 2 to find the median value. So how do we find the median? The median is the middle point in the dataset. To find the median, arrange the data points from smallest to largest. Next, if the number of data points is odd and the median in the middle point in the list. Next is if the number of data points is even, the median is average of the two middle data points in the list. Next slide po. So here are the formula to find the median of odd numbers. Next pa po, press. First, we arrange the data in either ascending or descending order. Let n denote the number of data values. If n is odd, then the median of odd numbers can be found using the formula. For formula to find the median of odd numbers, we first arrange the data in ascending. So we have 3, 9, 7, 6, 5, 2, 8, 11, and 9. So if we arrange the data in ascending order, as shown below, now we have 2, 3, 5, 6, 7, 8, 9, 9, and 11. Since we have 9 data values, we have that 9, and it is an odd number. Therefore, we now use the formula above. Next, press. Applying the formula, median is equals to 9 plus 1 divided by 2. Now we have 9 plus 1 is equals to 10 divided by 2, and the median is 5. As you can see, to the set of data values, the fifth term is equals to 7. Therefore, 7 is our median. Next po. Next reporter po.
So yun po, good afternoon sir. Naririnig po ba ako?
Yes, go ahead.
Okay po, sige po. So guys, I'm going to tackle about mode. But first, what is mode? Mode is the value that appears most frequently in a data set. A set of data may have one mode, more than one mode, or no mode at all. Other popular measures of central tendency include the mean or the average of a set and the median, the middle value in a set. So next is understanding the mode. In statistics, the mode is the most commonly observed value in a set of data. For the normal distribution, the mode is also the same value as the mean and median. In many cases, the modal value will differ from the average value in the data. And next po, please. Okay, so here's how to understand the mode. In statistics, data can be distributed in various ways. The most often cited distributions in the classic is the classic normal or bell curve distribution. In this and some other distributions, the mean average values falls at the midpoint, which is also the peak frequency of observed values. For such a distribution, the mean, median, and mode are all the same values. This means that this values is the average value, the middle value, and also the mode, the most frequently occurring value in the data. Next po. So here are some examples of mode. For example, in the following of list numbers, 16 is the mode since it appears more times in the set than any other numbers. So yun, guys, you can see here in the example that 16 is the most number that has more appearance than any numbers. So guys, pagka nakakita kayo ng mas maraming numbers sa mga nag-appear dito, katulad niyan 16, tatlo yung nag-appear. So 16 yung magiging mode since siya yung pinakamaraming appearance. So next is a set of numbers can have more than one mode. This is known as the bimodal if there are two modes, and if there are multiple numbers that can occur with equal frequency and more times than the others in the set. So yun guys, dito naman sa pangalawang example, makikita nyo naman yung dalawang dalawang mode. May dalawang mode dyan sa example na yan. Kasi makikita nyo yung 3, tatlong beses siyang nag-appear, and yung 16, tatlong beses din nag-appear. So ang tawag naman dyan guys is bimodal mode. So yun, next po. Mode. In the above example, both the number 3 and the number 16 are modes as they each occur 3 times and no other number occurs more often. If no number in a set of numbers occur more than once, that set has no mode. So yun guys, pagka naman wala kayong nakita sa isang set na ulit, kunwari tigi-tigisa lang silang nag-appear, yung 3, 6, 9, 16, 27, 37, and 48, yun ay no mode. So a set of numbers with 2 modes is bimodal. A set of numbers with 3 modes is trimodal. And any set of numbers with more than one mode is multimodal. So yun guys, to clarify these examples, meron ako ipapakitang mga pictures sa next slide. So ayan guys. Sa example 1, makikita nyo yung no mode. Kasi walang ni isa sa kanila na dalawang beses na naulit or tatlo. Then sa example 2, makikita nyo naman na yung 3 ang merong appearance na tatlo rin. So ang tawag dyan guys, kapag tatlong beses nag-appear ang isang number is trimodal. Tapos sa pangalawa naman guys, sa pangatlo, itong next is bimodal since dalawang number yung nag-appear ng tatlong beses, yung 3 and 9. So dito sa pangatlong example, merong dalawang modes which is bimodal. So yun lang. Next reporter na po, please. Thank you.
Good afternoon, everyone. I am John Andre Asuncion, and I will be reporting about the measure of dispersion. But first, we have to understand what is dispersion. Dispersion is the state of getting dispersed or spread. Statistical dispersion means the extent to which numerical data is likely to vary about an average value. In other words, dispersion helps to understand the distribution of data. The measures of dispersion help to interpret the variability of data or to know how homogeneous or heterogeneous the data is. In simple terms, the measures of dispersion shows how squeezed or scattered the variable is. Next slide. So there are two types of measures of dispersion. The measures of dispersion help to interpret the variability of data to know how homogeneous or heterogeneous the data is. So there are two main types of measures of dispersion, the absolute measure of dispersion and the relative measure of dispersion. Next slide. So the absolute measure of dispersion contains the same unit as the original data set. The absolute dispersion method expresses the variations in terms of the average of the deviations of observations like standard or mean deviations. It includes mean, median mode, range, upper and lower quartiles, variance, and standard deviation. Most of these types of absolute measures of dispersion will be discussed later in the report. While the relative measure of dispersion are used to compare the distribution of two or more data sets. These measures compares values without units. Common relative dispersion methods include the coefficient of range, coefficient of variation, coefficient of mean deviation, coefficient of quartile deviation. Next. Next pa. So the first type of measure of dispersion, the range, The range is the difference between the largest and the smallest observation in the data. The prime advantage of this measure of dispersion is that it is easy to calculate. On the other hand, it has lot of disadvantages. It is very sensitive to outliers and does not use all the observations in a dataset. It is more informative to provide the minimum and the maximum values rather than providing the range. Next. So here are the formulas for range. The range for the basic formula for range together with the group data is equals to the highest value of the data set, subtract it with the lowest value of the data set. While for the ungrouped data, the range is equals to upper class boundary of the highest interval, subtract it with the lower class boundary of the lowest interval. Next. The range is the difference between the largest and the smallest observation in the data. The prime advantage of this measure of dispersion is that it is easy to calculate. So the example here is to find the range of the data given data set, the 21, 6, 17, 18, 12, 8, 4, and 13. So to find the range, we have to arrange it. We have to find the highest value, which is equals to 21, and the lowest value, which is equals to 4. So the formula for range is equals to the highest value subtracted with the lowest value. So 21 minus 4. So the range is equals to 17. Next reporter.
Good afternoon, everyone. I'm Stephanie Alcantara, and I'm going to discuss about variance. So variance is a measurement of how far each number in dataset from the mean average, and thus from every other number in the set. Next slide. Variance is a measurement of the span of numbers in a dataset. The variance measures the distance each number in the set is from the mean. Variance can help determine the risk an investor might accept when buying an investment. Ronald Fisher developed the analysis of variance method. It is used to decide the effect of solitary variables have on a variable that is dependent. It may be used to compare the performance of different stocks over time. In quantitative methods, the variance of a set of data points is measured of its spread or variability. It is calculated by taking the average of the scatter difference between each data point and the data set mean. Each are some examples of how variance can use in different scenarios. Example number 1 is exam scores. Consider a scenario which you are interested in the exam performance of the group students. If the exam score variance is significant, it means the students falls within a wide range and the results are separated. A low variance, on the other hand, shows that the scores are most closely related to each other and the learner's performance is more reliable. In financial returns, imagine you are reviewing the performance of a portfolio of investments over a specific time period. Given that the returns are more unpredictable and regular when the variation in the returns is high, the portfolio is a higher risk. On the other hand, if the variation is limited, the returns are more steady and consistent. In height of people, consider taking measurements of a group people's height and figuring the range of their heights. When the variance is large, it means the group member heights are separated, that there is wide range of heights. On the other hand, if the variance is low, means that there is a less variation in height, that the group members are more closely distributed around the mean. In quality control, let's say you are weight to finished products to evaluate how well a manufacturing process is going. If there is a lot of variance and the process is not particularly consistent, and the product weights are very unpredictable. The process is more constant and product weights are more closely grouped around the mean of the weight, and the variation is small. Next reporter, please.
So hello everyone. I'm Katara Koon. So I'm assigning to standard deviation. So standard deviation is a statistic that measures the dispersion of a dataset relative to its mean and is calculated as the square root of the variance. The standard deviation is calculated as the square root of variance by determining each data point's deviation relative to the mean. If the data points are further from the mean, there is a higher deviation within the dataset. Thus, the more spread out the data, the higher the standard deviation. Next. So standard deviation, a statistic that measures the dispersion of a dataset relative to its mean and is calculated as the square root of the variance. Next. So understanding the standard deviation. Standard deviation is a statistical measurement in finance that, when applied to the annual rate of return of an investment, sheds light on that investment's historical volatility. The greater the standard deviation of securities, the greater the variance between each price and the mean, which shows a larger price range. For example, a volatile stock has a high standard deviation, while the deviation of a stable blue chip stock is usually rather low. Next po. So, so kung makikita nyo, ito po yung example po ng standard deviation formula. So, standard deviation formula is calculated by taking the square root of a value derived from comparing data points to a collective mean of a population. Next. Using standard deviation is an especially useful tool in investing and trading strategies, as it helps measure market and security volatility and predict performance trends as it relates to investing. For example, an index fund is likely to have a low standard deviation versus its benchmark index as the fund's goal is to replicate the index. So here is the example of standard deviation. So let's say we have the data points 5, 7, 3, and 7, which total is 22. You would then divide 22 by the number of data points. In this case, for resulting in a mean of 5.5, this leads to the following determinations: x equals 5.5 and n is equals to 4. So next reporter.
So measures of shape. Measures of shape describe the distribution or pattern of the data within a dataset. The distribution shape of quantitative data can be described as there is a logical orders to values, and the low and high end values on the x-axis of the histogram are able to identify. The distribution shape of a qualitative data cannot be described as the data are not numeric. And the uses of measures of shape. The shape of a distribution can assist with identifying other descriptive statistics, such as which measures of central tendencies appropriate to use if the data are normally distributed. The mean, median, and mode are all equal and therefore are all appropriate measures of central tendency. If data are skewed, the median may be a more appropriate measures of central tendency. Next page po. Shapes of data set. Distribution of data item values may be symmetrical or asymmetrical. Two common examples of symmetry and asymmetry are the normal distribution and skewed distribution. Symmetrical distribution, in a symmetrical distribution, the two sides of the distribution are a mirror image of each other. A normal distribution is a true symmetric distribution of observed values. When a histogram is constructed on values that are normally distributed, the shape of columns form a symmetrical bell shape. This is why this distribution is also known as a normal curve or bell curve. Next. The following graph is an example of a normal distribution in the heights of the students po. Ayan po yung graph na example of the normal distribution. And next. And ito naman po yung example ng bell curve. And if represented as a normal curve or bell curve, the graph would take the following shape. Next po. Ay, di na. Next reporter na. Ay, akin pa rin pala yan. Ay, hindi na pala sa akin pa ba yan? Okay, so key features of the normal distribution, symmetrical shape, mode, median, and mean are the same and are together in the center of the curve. There can only be one mode. There is only one value which is most frequently observed. Next. Most of the data are clustered around the center, while the more extreme values on either side of the center become less rare as the distance from the center increased. About 68% of the values lie within one standard deviation away from the mean. About 95% of the values lie within the two standard deviation, and about 99.7% are within three standards deviation. This is known as the empirical rule or the 3 sigma rule. Next. Okay, thanks. Asymmetrical distribution. In asymmetrical distribution, the two sides will not be mirror images of each other. Skewness is the tendency for the values to be more frequent around the high or low end of the x-axis. When a histogram is constructed for skewed data, it is possible to identify skewness by looking at the shape of the distribution. For example, A distribution is said to be positively skewed when the tail on the right side of the histogram is longer than the left side. Most of the values tend to cluster toward the left side of the x-axis, with increasingly fewer values at the right side of the x-axis. Next. Ayan po yung example ng positively skewed distribution ng height of the student or height of students. Okay, next po. Measures. A distribution is said to be negatively skewed when the tail on the left side of the histogram is no longer than the right side. Most of the values tend to cluster toward the right side of the x-axis, with increasingly less values on the left side of the x-axis. Next po. Naglag na ba? Next, press. Ayan naman po example ng negative skew distribution ng height of the students po. Ayan na. Key features of skew distribution: asymmetrical shape, mean and median have different values and do not all lie at the center of the curve. There can be more than one mode. The distribution of data tends towards the high or low end of the data set. Next. Other possible distribution shapes. Other distribution include unimodal, bimodal, or bimodal. A unimodal distribution occurs if there's only one peak, a highest point in a distribution as seen in the previous histogram. This means there is one mode, a value that occurs more frequently than any other for the data item or variable. The distribution shape of the data in the histogram below is a bimodal because there are two modes, two values that occur more frequently than any others for the data item. Next po. Yan po yung example ng bimodal distribution ng height of the students, kung saan po meron po silang dalawang mode. Next. Uses of measures of shape. The shape of distribution can assist with identifying other descriptive statistics, such as which measures of central tendency is appropriate to use. If the data are normally distributed, the mean, median, and mode are all equal and therefore are all appropriate measure of central tendency. If data are skewed, the median may be a more appropriate measure of central tendency. Next.
Good afternoon, everyone. I'm Jenny Bahan, and I will discuss the skewness. What is skewness? It's probability theory, and the statistics skewness is a measure of a symmetry of the probability distribution of a real value, random value about its mean. The skewness you can be positive, zero, or negative or undefined. There's three types of skewness. Skewness, also called passive skew. A skewed distribution is longer on the right side of its peak than on its left. Left skew is also called negative skew. The skewed distribution is longer on the left side of the peak than on its right. Zero skewed is symmetrical, and its left and right side are mirror images. For uneven distribution, negative skew commonly indicates that the tail of the left side of the distribution, and positive skew indicates the tail of it's on the right. In the case where one tail is long but the other tail is fat, skew does not obey the simple rule. For example, a zero value means that the tails on the both sides of the mean balance out overall. It's a case of symmetric distribution, but can also be true as for an asymmetric distribution where one tail is long and thin and the other is short but fat.
Next slide, please. You can see on the screen, we have a right screw, zero screw, and left screw. The number of suns observed per year, shown the historical below is an example of right screw distribution. The sun spots were the dark color areas on the surface of the sun. Were observed the astronomers between 1940 and 1893. The second picture on the screen is zero screw. Zero screw is mean median. For example, the mean take weight is 261.3 gram and the median is 258 gram. The mean and the median are almost equal, but they aren't perfectly equal because the sample distribution are very small screw. And the lastly is negative screw. Is the distribution is left screw because it's longer on the left side of peak, but the long tail is that its left represent the small proportion of students who receive very low score. Next presenter, please.
Good afternoon, everybody. I'm Harvey Nicole Banag, and today I will discuss about kurtosis. In quantitative methods, kurtosis is a metric that quantifies the statistical form of a dataset's probability distribution. In relation to the normal distribution, it highlights how peak or tails the distribution. When a dataset's kurtosis is high, it means the data have a strong peak and thick tails, whereas when it's low, the data are more widespread and have thinner tails. Next slide, please. Here are the types of kurtosis. First, we have mesokurtic. With a kurtosis of zero, a distribution that has the same amount of peaks and tails as a normal curve without any kind of outliers. The dataset is indeed distributed symmetrically around the mean. The second one is leptokurtic. Distribution has a positive kurtosis, which denotes that it has a longer tail and far more peaks than a normal distribution would. This shows that the data is more dense in quantities near the mean and more likely to have extreme values in the tails. Next slide, please. The third one is platykurtic. Its distribution is flatter and lighter tailed than a normal distribution because it has a negative kurtosis. This shows that the distribution of the data is wider. There are fewer values near the mean, and there is less of a chance that the extreme values in the tails will occur. Next slide, please. This is the graph of the three types of kurtosis. As you can see, the first one is the density plot, and the second one is normal quantile plots, where you can see mesokurtic have the distribution of the same amount, and leptokurtic has the highest peak, and platykurtic has the normal one. Next slide, please. Here are some few examples of kurtosis in quantitative methods as follows. First one is the stock market returns, because it has a returns have a high kurtosis and have often widely dispersed. This suggests that The returns have a strong peak and thick tails, indicating that the distribution contains more extreme values than a normal distribution would. The second one is client long-term value. Lifetime value distribution could show a positive kurtosis, suggesting that a small number of high-value clients considerably boost the business overall revenue. The last one is test results may be distributed with a negative kurtosis, which denotes a score distribution that is less centered on the mean and more dispersed than a normal distribution. Next slide, please. Here are the references of our report. Next slide. That's all. Thank you for listening.
Okay, so thank you very much. I have encountered problem with my video, no? But again, wait. Okay. So as what you have mentioned earlier, no, your topic focus on the descriptive statistics, no. So you give it already some additional example, no. So if you want a good example of descriptive statistics, look no further than a student grades points, no, average, no. So a grades point average gather the data points, no, created through a large selection of grades, classes, and exams, then average them together and present a general idea of the students' main academic performance, no. So there are different types of descriptive statistics, no. Descriptive statistics break into several types, no, characteristics or measures. And some authors say that there are two types. No, others say that 3 or even 4. Number one, of course, is the distribution, or so-called frequency distribution. Data sets consist of distribution of scores or values. Statisticians use graphs and tables to summarize the frequency of every possible value of a variable, rendered in percentage or numbers. For instance, if you held a poll to determine people's favorite beetle, no, you've set up one column with all possible variables. Let's say, for example, Jose, Juan, John, at saka Paul, and another with the number of votes. So statisticians depict frequency distribution as either a graph or as a table. So another is the measure of central tendencies. Now, a measure of central tendencies estimate a data set's average or a center, finding the result using 3 methods, that is mean, median, and mode. So the mean is also known as M and is the most method for finding averages. The mode is just the most frequent response value. So data sets may have any number of modes, including 0. You can find the mode by averaging data sets number order and the lowest of the highest value, and then looking at the most common response. Median, finally, we have median. We have the median defined as the value in the precise center of the data set. Arrange the values in descending order, like we did last time, no, and look for another in the set's middle. In this case, the median is 8. No? Then we have, of course, you discussed a while ago about dispersion. This is the variability actually. The measure of variability gives the statistician an idea of how spread out of responses are. And the spread has 3 aspects. We have the range, standard deviation, and the variance. Range is used use range to determine how far apart the most extreme values are. Start by subtracting the data set's lowest value from its highest value. So once again, we turn to our sleep study. Let's say, for example, 4, 6, 7, 8, 9, 10. We subtract 4, the lowest, from 10, the highest, and get 6. there's your range. No, the standard deviation, on the other hand, this aspect takes a little more work actually, because the standard deviation is your data set's average amount of variability, showing you how far it's score-lies from the mean. So the larger your standard deviation, the greater your data set's value. Let's say, for example, no, list the score and their means, find the deviation by subtracting the mean from each score, square its division or deviation rather, total up all the square deviation, divide the sum of the square deviation by n minus 1 and find the result of square root. So when you derive the sum of the square deviation by, let's say, 6, n minus 1, that is 23.83 by 6, you can get 3.978, and the square roots of the result is 1.992. As a result, we know that each score deviates from the mean by an average of 1.922. Variance, on the other hand, refers to the data set's degree spread. So the greater the degree of the data spread, the larger the variance relative to the mean. So you can get the variance, no, by just squaring the standard deviation. Okay, so we have also what we call univariate descriptive statistics. So univariate descriptive statistics examine only one variable at a time and do not compare variables. Rather, it allows the researcher to describe individual variables. As a result, this sort of statistic is also known as descriptive statistics. The pattern identifies in this sort of data may be explained using the measure of central tendency, data dispersion, table of frequency distribution. We have pie chart, frequency polygon histogram, and bar graphs. We have also what we call bivariate descriptive statistics. When using bivariate descriptive statistics, two variables are concurrently analyzed or compared. So to see whether they are correlated, generally by convention, the independent variable is represented by a columns and the rows represent the dependent variable. Actually, there are numerous real-world applications of bivariate data. Let's say, for example, estimating when a natural occurrence will occur is quite valuable. Now, bivariate data analysis is a tool in the statistician's toolbox. Sometimes, something as simple as projecting one parameter against the other or a two-dimensional plane can better understand what the information is trying to convince you. Let's say, for example, the scatter plot demonstrates the link between the period between eruptions of Old Faithful and the eruption duration. So, what will be the main purpose of a descriptive statistics? Descriptive statistics can be useful for two things. Number one, providing basic information about variables and data set. Number two, highlighting potential relationship between variables, because graphical or pictorial methods are measures of the three most common descriptive statistics between that can be displayed graphically or pictorially. It is used to summarize data, and descriptive statistics only makes a statement about the data set used to calculate them. They never go beyond your data. So scatter plots. So a scatter plot employs dots not to indicate values for two separate numeric variables. Each dot's location on horizontal and vertical axis represent a data point's value. So scatter plots are being used to monitor relationship between variables. And the main purpose of scatter plots are to examine and display relationship between two numerical variables. So the points in a scatter plot document the values on individual points and trends when a data is obtained as a whole. So identification of correlation links is prevalent with scatter plots. In this situation, we want to know what a good vertical value prediction would be given a specific horizontal value. So this can lead actually to overplotting when there are many data points to plot. When data points are overlaid to the point where it is difficult to see the connections between them and the variables, this is known as overplotting. It might be difficult actually to discern how densely packed data points are when lots of them are in a tiny space, because there are a couple of simple methods to relieve this concern. One approach is to choose only a subset of data points A random sample of points should still offer the basic sense of patterns in the whole data. Additionally, we can alter the space or the shape actually of the dots by increasing the transparency to make overlaps visible or decreasing point size to minimize overlaps. So, actually, there is a difference between inferential and descriptive statistics, and maybe somebody were assigned to discuss an inferential statistics. Okay, I think that's it for this topic.